In today's video, I will demonstrate the power of string interpolation before digging deeper into variables and their declaration in Kotlin. Hello and welcome to Learn with Tam. I am Tariq Ali Mirza and my goal is to make you a kick-ass Android developer. If you are new here, I suggest that you start watching this series from the beginning to get the most out of it. In the last video, I began introducing you to the basics of Kotlin for Android developers. In today's video, I'll teach you about mutable and immutable variables before demonstrating the difference between type inference and annotation in Kotlin. But before we get to that, I'll introduce you to string interpolation in Kotlin. So, without further ado, let's jump right into our system and get started. Let's begin by opening Android Studio. Now open the project from the previous lecture. If your Kotlin file is not open by default, go to your Project Explorer, click on the arrow next to App, then click on the arrow next to Java, and then open your package folder. And there you will find the file because that is where we created it. Now double click on it to open it. In case you did not follow the previous lecture, I strongly recommend that you go and watch that lecture before coming here. String interpolation helps us in referencing our variables as well as expressions within strings. Let me type down the first example and then I'll explain what's happening. I have created a sentence variable to store a string. And in that sentence variable, I am storing Tam is $age years old. The dollar here is a special symbol that tells Kotlin that whatever follows it is the name of a variable. As soon as the compiler gets to this point, it replaces the $age with the value that is stored within the variable age. And in our case, that is 32. Let me print this sentence so that you can see exactly what's happening. I have commented out the previous print statements so that our console window is not cluttered with text. Now let's run this program by clicking on the green play button and selecting run basic.kt. As expected, it prints Tam is 32 years old. $age in our text was replaced with the value stored within the variable age, and that was 32. So it did exactly what we expected it to do. Just so you know, we did not even have to create this extra variable named sentence. We could have written this text directly within the print statement. Let me show you how. I have removed the extra variable and put the text directly within the print statement. Let me run it once again. As you can see, the output does not change at all. And that's not all. There's a lot more you can do with string interpolation. Let me show you another example. What you are seeing right here is another example of what you can do with string interpolation. As you can see, I am even performing a mathematical operation within the string. Just to be clear here, when you are referring to some variable within your strings, you use the $sign. But when you need to add an entire expression within your string, you need to use $ along with the curly braces, and the entire expression needs to go within those curly braces. Let me show you the output. As you can see, the first output remains the same, Tam is 32 years old. But we have the second output as well. The sum of 32 and 65.5 is 97.5, which is mathematically correct. The $age within the string was replaced with the number 32, that is the value of the age. The $weight in the string was replaced with the number 65.5, that is the value of the variable weight, and the sum of age and weight was replaced with the actual sum of the values. I will not spend another hour showing you all the different expressions that you can put within those curly braces. You get the idea. As long as the expression is correct, you can add it within the curly braces and Kotlin will not complain. It will just take the expression that it finds within the curly braces that is followed by the $sign and replace it with the result. Let me close the output window so that we can concentrate on the next topic. Up until now, I have been using the keyword var to declare all my variables. And I don't know whether you have noticed it or not, but Android Studio has been complaining for quite some time now. Let me uncomment all the code from the previous lecture so that you can see Android Studio complaining. Please note that I am using the keys Ctrl and / to comment and uncomment my code. As is very much visible right now, all my variables have been highlighted by Android Studio. That's because the keyword var is used to declare mutable variables, which implies that their value can be changed once it has been assigned. For example, if I assign another value to age in a later part of this program, then Android Studio will no longer complain about age. Let me show you that. As you can see, the highlight from the variable age is now gone, but the highlight in all other variables still exists. What is it trying to say? Let's read. Variable is never modified and can be declared immutable using val. Here Android Studio is trying to tell us that why don't we declare these variables as immutable variables, because we are never changing them once they have been assigned. And that makes sense. So let us change all our mutable variables to immutable variables, because we are not going to change the value of these variables once they have been assigned. Now I am declaring all the variables as val, which means they are immutable. If I try to change my age now, Android Studio should not allow me to do that. As you can see, Android Studio is now complaining that val cannot be reassigned. So maybe I should try incrementing my age. So it won't even let me add a number to my age, which is exactly what we expect from immutable variables. I will clear this part. Let me run this program once again so that you can see that nothing has changed even though we have changed our variables from being mutable to immutable. As we had seen in the previous video, the first output is age, the second output is weight, the third output is my savings, the fourth output is my profession, the fifth output is gender, the sixth output is the address, which is a multi-line string, so it spans over 3 lines. Then there is isNinja, which is false, and then there is isCoder, which is true. And at the end, we have today's print statements. Tam is 32 years old, and the sum of 32 and 65.5 is 97.5. Even though we changed our variables from being mutable to immutable, nothing changes in our program. Everything remains the same, apart from the fact that now we are writing better code. To sum it up, if you intend to change the value of a variable sometime later in the program, use var for it. And if the value of a variable remains the same throughout the execution of a program, you should use val for it. I close the output window once again and comment out all the print statements. Now let's move on to the next topic. Kotlin is a statically typed programming language, which implies that once the type of a variable has been identified, you cannot use the same variable to store a different type of data in it. For example, our age variable as of now is storing an integer. Let me try to store a string within that variable. As of now, Android Studio is complaining because we are trying to assign a new value to an immutable variable. Let us change the age variable to mutable once again so that we can try this out. Now the variable age is mutable, which means we can change its value or replace its value. But the Android Studio IDE is still complaining. Let us see why. It is saying there is a type mismatch. The required value is of a type int, whereas we have provided a string to it, which is exactly in line with what we expect. In case you are wondering how does Android Studio know that age should always be an integer, let me take you back to line number 7 where we have declared the variable. We said that the variable age is of a type integer and then we stored an integer value within it. That is how Android Studio identified the age variable to be of type int. This approach of providing the type of the variable after colon within the declaration of the variable is known as type annotation. But there is another way in which we can declare variables. Let me show it to you. As you can see on line 20, I have not provided the type of variable unknown. but the IDE is still not complaining. When I hover over unknown, I can see var unknown of type int. Even though we did not tell the IDE or the Kotlin compiler that we intend to store integers into it, they inferred it from the value that we were trying to store in it. Since 30 is an integer, the type of value that can be stored in unknown is an integer, and therefore the type of variable that unknown can store is now an integer. If I now try to store some text value in unknown, the IDE should start complaining. Let me show you that. As you can see, the IDE is once again complaining of a type mismatch. It says that we required int, but I have provided a string. This approach, in which you do not provide the type of the variable while declaring it, is known as type inference. So, we can declare variables in two ways. We can either provide the variable type by using type annotation, or let the compiler decide the type of the variable by using type inference. I will remove type annotations from all the variables so that you can see the output and it should remain unchanged. As you can see, I have removed type annotations from all my variable declarations and the IDE is not complaining at all. Let me uncomment all the print statements. And now I will run this program so that you can see the output. As you can see, the output remains unchanged. At this point, I would like you to focus on variable weight on line 8. I know, that sounds poetic, but that is exactly where it is situated. In the last lecture, I told you that the f next to 65.5 is necessary for the Kotlin compiler to be sure that you intend to save 65.5 as a float and not as a double. In case of type inference, it is coming in handy and the type of weight would still be float and not double. When we hover over weight, you can see the val weight is of type float. It is not of type double. If I remove the f right now, then the type of weight will become double. Now I have removed the f next to 65.5 and let's hover over weight. As you can see, the type of weight is now double. I will keep it as double for now. As you might have already noticed, programming in Kotlin is not as difficult as it initially appeared. The creators of Kotlin have added features to the programming language to make your life easy as a developer. For example, the nullable type and the safe call operator, both of which we are going to cover in the next lecture. That's all for today's video. As always, feel free to share your valuable thoughts and feedback in the comment section. If you like the video, smash that like button. If you are new to the channel, consider subscribing. And don't forget to hit the bell icon to receive timely updates of all future uploads. I'll see you in the next one.